Friends, good afternoon everybody. In the last video we have discussed theorems on triangles as well as Pythagoras theorem. Today we will discuss few examples which are based on the Pythagoras theorem, and then we will proceed towards the exercise 6.5. Okay. The example number 10 which is given in your book is this. In the given figure, angle ACB is 90 degree and this CD is perpendicular to AB. Then prove that BC square by AC square, BC square by AC square is equal to BD by AD. Now you see, this BD is in this triangle and AD is in this triangle, while BC and AC are in the bigger triangle. Means we have to prove this triangle similar to bigger one as well as this triangle also similar to bigger one, and then we will take the ratio of the sides. Okay. So let us prove. Suppose this angle is theta. So it again ACB, again this is theta, means this angle becomes 90 minus theta. Now sum of all the three angles will be 180. Out of 180, this angle is 90. So sum of these two angles also should be 90. Out of these two angles, one is theta, so there will be 90 minus theta. Again here, if you compare in this triangle, this angle is 90. So sum of these two angles should be 90. Out of these two angles, this is 90 minus theta, means this angle is theta. And this whole angle is 90 degree. Out of this angle is theta. So this angle is 90 minus theta. Okay. Now we have to take a triangle ACD and triangle ABC. Clear? Let us draw a rough figure, separate rough figure for both the triangles. This is the triangle AD and C, where this angle is theta. This angle is 90 minus theta. Okay, and the bigger one triangle is like this. This is the angle C. This one is A, which is theta, and this is C, which is 90 minus theta. Now you see in this, both the triangles are similar because angles are all equal. And so you can say angle A is equal to angle A, that is equal to theta, which is common. And then angle ACD is equal to angle C, which is 90 minus theta. That means the triangle ACD is similar to triangle ABC by angle similarity. Okay. Now we need to side BC by AC. That is BC. Sorry, this is your angle B. That is BC by AC. So BC by AC we have taken from the bigger triangle. Now we need to take the corresponding sides from this triangle. Now you see this BC is the side which contains 90 minus theta and 90. So 90 minus theta and 90 is on side BC. So corresponding to BC will be the side CD. Okay. And then AC is the side which contains angle 90 degree and theta. 90 degree and theta is on AD. So corresponding to AC is AD. This is the first equation. Okay. Similarly, we will prove this triangle similar to the bigger one. That is in triangle ABC and triangle CDP. Okay, let us draw a rough figure from this. This is the triangle CDB. This angle is 90. This angle is 90 minus theta, and this angle is theta. Okay. Again, rough figure of the bigger one. This is C, this side is A, and this is your B. again we can take this angle A is equal to angle BCB is equal to theta degree. Angle A is equal to angle BCB, which is theta, and angle B is equal to angle B, that is common. Okay, so again this triangle ABC is similar to triangle. Now we are taking the name as ABC, means theta 90 minus theta and then 90. So theta 90 minus theta and then 90, that is CBD, triangle CBD, right? Angle similarity. Okay, again we need the side BC by AC only, because here we have taken BC by AC. So again we are taking this BC by AC. Now we will look for the corresponding sides from this triangle. So BC by AC, BC is the side containing 90 degree and 90 minus theta. So corresponding to this 90 and 90 minus theta is on BD. So corresponding to BC is BD. And AC is the side containing 90 and theta. So 90 and theta is on side CD. So corresponding to this side CD. Okay. Now we need square of BC by AC. Means we will multiply both the numbers. Okay. So multiplying equation 1 by 2 will get the square of BC upon the square of AC. Now BC by AC into BC by AC, that is the square of BC by square of AC, is equal to CD by AD into BD by CD. Now BC by AC is CD by AD and BC by AC is BD by CD. Now you see this CD is cancelled, so we get this BD by AD. Okay. Example number 13 is given that BL and CM are the medians of a triangle ABC, which is right angle at A. Means this angle is right angle, and in this triangle this BL and CM are the medians. Okay, and then we have to prove that the 4 times of square of BL plus square of CM is equal to 5 times of square of BC. Okay, so let us prove it. First, as BL and CM are the medians, so property of medians is that it divides the base into equal parts. Now that means as this BL is median, so CL is equal to LA, which is equal to half of AC. Now these both parts are equal, means half of AC. So this also half of AC, this also. Similarly, this CM is median. CM is median, means it divides the AB into 2 equal parts. So this gives us AM is equal to BM, can be written as a half of AB. Okay. Now in triangle ABC, this angle is right angle. Means we can write the square of BC as a square of AB plus square of AC. Okay. Now we need the square of BL. BL is in triangle BAL. So we'll use in triangle BAL square of BL is equal to square of AL and plus square of AB. Now the square of hypotenuse is equal to sum of the squares of the other two sides. Clear? Now LA or KL can be replaced with half of AC. So this can be written as a half of square of AC plus square of this becomes 1 by 4 times the square of AC plus the square of AB. Okay. Now here the denominator is 4. So we will multiply each term by 4. So if you multiply this term by 4, this becomes 4 times of the square of BL. This 4 is cancelled. This becomes the square of AC. This becomes 4 times the square of AB. Clear? Similarly, we need the square of CM also, and CM is in triangle AMC. So in triangle AMC, the square of CM is the hypotenuse, is equal to sum of the squares of other two sides, means the square of AC and plus the square of AM. Okay, now this is the square of AC, this AM. AM can be replaced with the half of AB. Again, this becomes the square of AC plus 1 by 4 times of the square of AB. Now we will multiply each term again by 4 because this contains the denominator as 4. So this becomes 4 times of the square of CM is equal to 4 times of the square of AC plus the square of AB. Okay. Now we need the sum of the squares of BL and CM. So squares of BL and CM is there. So we will add 1 and 2. Adding 1 and 2. This 4 times of BL square plus 4 times of CM square can be written as a 4 times as a square of BL plus square of CM. Okay, which is equal to AC square plus AC square here and 4 AC square here. 1 AC square is here and 4 AC square here. This becomes 5 times of AC square. Similarly, 4 times of AB square is here and 1 time of AB square is here. This becomes 5 times of the square of AB. Now you can take 5 as a common. This reduces to AC square plus AB square. Now in the beginning we have written this AB square plus AC square is equal to BC square. So this can be replaced with the square of BC. Okay. Okay. So question is that PQR is a triangle which is right angle at P and M is a point on QR such that PM is perpendicular to QR. So we need to draw a figure for this. Let's draw a figure. Suppose this is the triangle. This is PQR, right angle at P. PQR is a triangle, right angle at P. And M is any point on QR such that PM is perpendicular to QR. Okay? Then we have to show that the square of PM is equal to square of QM into square of MR. Means QM and MR is in these two triangles and PM is the common side of these two triangles. Means we need to prove these two triangles as similar. Okay? So we will follow the same procedure. That this angle is again theta. So what about this angle? As this is 90, this angle is theta. So this angle becomes 90 minus theta. Again this whole angle is 90. Out of this is 90 minus theta. So this angle is theta. Now again this is theta, this is 90, and this angle becomes 90 minus theta. Clear? Now we will prove similar. The triangle P and Q and triangle P and R. Okay, two angles Q and angle MPR is theta. So angle Q is equal to angle MPR. which is equal to theta. Similarly, these two angles are 90 minus theta. That is again QPM is equal to angle R, which is 90 minus theta. Okay, now two angles are equal. That means triangle PMQ is similar to triangle PMR, not PMR. We are taking this PMQ. P 90 minus theta, then 90, then theta. So 90 minus theta, and 90, and then theta. That is RMP. Okay, biangle similarity. Now we need the ratio of these two sides, PM by QM. Now PM is common, QM is in this triangle. So we will look for the corresponding names in the other triangle. So if you see this PM is the side which contains 90 minus theta as well as theta. So corresponding to this, PR is the side which contains theta and 90 minus theta. So corresponding to PM is PR. Okay? Sorry, not PM. Here we are taking PM. PM is the side which contains 90 and 90 minus theta. So corresponding to this side contains 90 minus theta and 90. Okay? So corresponding to PM is MR. And QM is the side which contains theta and 90. So theta and 90 is based on PM. So corresponding to PM is QM is PM. Now we need PM square, means we need to cross multiply. This becomes the square of PM is equal to MR into QM. QM into MR. Okay, so we got our result, that is into, or you can represent with dot also. Okay, so go through this video once again and try to solve exercise 6.5. Good day.